Hi everybody, this is Annabelle Guest from the Dryland Cotton Research Association. Sorry I can't be with you in person today, but today I'm going to present to you a summary of the last 3 years of the development of ultra-high pressure water cutting, or Aquatill for cotton termination. Ultra-high pressure water cutting is also being concurrently developed in rice and cereals for cutting through stubble and planting into. In the first year of development, a scoping study was conducted by Paul Grundy at Qatar up at Moree, and this was looking at a basic ground engagement tool and applying water only through the Aquatill system. Unfortunately, quite a lot of regrowth occurred when water only was used, so Paul extended the project and made the decision to add herbicide to Aquatill to see if more robust cotton termination could be achieved. The herbicide that he used was fluroxyper at 1/2 litre per hectare, and you can see here by looking at the row of cotton in front of the yellow flag there that the results achieved were very good, approaching 100% control. This 2017 year was a really good year to commence this work, as quite a lot of rain was received in March, which meant quite a lot of returning happened that year, and people saw returns growing from under the ground, which they hadn't seen before. And so we commenced to the second year of development, which was 2018. In this year, we looked straight at fluroxyper again and water only through the Aquatill system. NDF from Narromine came on board with the project and developed a basic ground engagement tool, which you can see here on the right-hand photo. In the 2018 year, 2 sites were put down at Narrabri in dryland cotton residue, one in standing stubble and one in mulched stubble. We treated this year in July, towards the end of July, and as you can see from the video, conditions were really dry and frosty and cold, and the plants actually weren't metabolizing very much at all. The results from the 2018 season were quite variable. Initially, we got good control, around 90% and a bit above at both the Lara and the Camus sites. But as you can see, after we got some rainfall in spring, quite a lot of regrowth occurred, as represented by the green bars in the graph above. And this meant that regrowth had occurred and the control was not robust. So in these sites in 2018, we looked at fluroxyper at 1/2 litre and 1 litre per hectare in a range of water volumes from 33 to 132 litres per hectare. Analysis of this data showed that application volume had little effect on the efficacy achieved. And so it was back to the drawing board for what to do in season 3. In season 3, which was 2019, NDF continued to develop their ground engagement tool. And you can see by this video here that the ground engagement tool that we used is treating 2 rows simultaneously. The requirements for the tool is to be able to handle the differences in stem size and the variation across the field. So it's really great to have NDF on board with this project and looking to commercialize the Aquatill ground engagement tool. In the 2019 trials, we treated in the first week of June. Conditions then were much warmer than in the previous year, and you can see some nicked plants in the photo there on the right-hand side. The plants were still showing some signs of metabolism, and previous year's work had shown us it was better not to cut right through the stem. So here we have the first trial at Carmona Downs, and you can see we have the Aquatill plot in the left-hand row compared to the untreated on the right, with really good results obtained. Some retaining did occur at this site, as you can see from the photo on the right-hand side. The control obtained at the Terry High site was very good, between 95 and 99% for 1 and 2 litres per hectare of fluoroxyper. And at this site, we evaluated volumes of 79 and 124 litres per hectare, as this is what the nozzle orifice allowed. We got significantly better control than where water only was applied, and also looked at slightly higher control than the commercial spray treatment regime. As you could see, this was a slashed site, but I had a couple of comparisons of standing cotton in there, as you can see on the right-hand side. So when we looked at the 1 and 2 litre rate, the 2 litre rate especially showed slightly looking more robust control than where the same treatment had been applied in slash cotton, providing some anecdotal evidence that standing cotton may return less than slashed cotton. The next site was at Narrabri PBI, and you can see here in this picture, we have a 2 litre and 79 litre treatment in the row of the left hand of the photo, compared to an untreated control in the right hand side. This site was quite a lot drier than the Carmona Downs one, which received 80 to 100 mils between assessments. At the Narrabri site, it was around 80 mils. So again, looking at the results, we received very good control, 95 to 100% at 1 and 2 litres per hectare. The application volumes we used here were 60 and 79 litres per hectare. Water only was slightly behind, so it was good to show control over that. And we also had a commercial slashed treatment in there for comparison. So anecdotal evidence showing that Aquatill provided better control than that treatment. A third site in 2019 was done up at Dalby in some irrigated cotton as requested by the grower. This site received 180 mils of rain over January, and these photos were taken about 2 weeks after treatment. So you can see the left-hand row in each picture is an untreated, and a right-hand row is an Aquatill plot. So we have 2 litres in 79 in the left, 2 litres in 124 in the left-hand side, 2 litres in 79 up the top. And these treatments have given very good robust control compared to the water-only treatment down the bottom. Results from the irrigated side at Dalby have again shown 94 to 98% control when we looked at fluoroxyper at 1 and 2 litres per hectare. Growers have indicated that 95% control of returns or higher is the number that they need for Aquatill to be considered an effective crop termination method. We got significantly higher control than where water only was applied, and than where the 1 litre per hectare treatment was used. Key messages from the 1920 season. Increasing the rate of fluoroxyper from 1 to 2 litres per hectare did provide more robust control, but also increased the cost of application. So going forward, we would probably look at a rate between these two numbers. The data has also shown that increasing water volume does not necessarily lead to increased efficacy, and we've looked at volumes everywhere from 33 to 132 litres per hectare. So the lower the volume that we can commercially work with, the more the benefit for growers by having to provide less water. We also saw some anecdotal evidence that standing cotton returned less and an Aquatill was more effective than on slashed or mulched stubble. Some growers prefer to treat standing stubble, while others prefer to slash or mulch, and then Aquatill what is left, depending on personal requirements. Moving forward, this year we had planned to do 5 demonstration trials with a multi-row unit, which was at least four rows wide, developed by NDF across the cotton growing areas. We also plan to do a replicated site in Bulgard 3 Extend Flex Cotton to demonstrate or trial the technology in that cotton, and also possibly look at other herbicides that we could apply through the system. Unfortunately, both these projects have been delayed due to COVID-19 and border travel restrictions. Other parts of the project that we need to complete is reporting the data to the APVMA for registration of fluroxyper through the Aquatill system. We'd also like to present this data to TIMS for consideration of the Aquatill as a crop termination method and that is consistent with the resistance management plan requirements. I would like to thank the Cotton Research and Development Corporation for continued funding of this project. And I would also like to thank Titan Ag, South Australian No-Till Farmers Association, FLO, the University of Sydney and NDF for their contributions to the project to date, which have been significant. Also, a thanks must go to Darren Hart, Ed Tomlinson, Ian Goulet, James Haylor, and the University of Sydney for providing trial sites over the last 3 years.